Okay, this is part 8 and the final part, in fact. I'm going to be posting up just a few more slides looking at one particular aspect, pardon me, 16.4 on page 420, Koch's postulates. So kind of expected that a microbiology student should leave a microbiology class knowing Koch's postulates, even though there's a lot of problems with them, and we'll look at those problems later on. So the idea is how to establish the cause of an infectious disease. So you have a person who is sick. You think it is being caused by a particular microbe, a particular pathogen. How do you know for sure that pathogen X is causing disease X? Robert Koch, very important figure in microbiology, set forth these postulates in his when he established that Bacillus anthracis causes anthrax. Bacillus anthracis is a spore-forming bacteria that, when it gets into the body, it produces a toxin, and that toxin causes then very serious disease and is often fatal. So Robert Koch saw that, indeed, infected mice with anthrax, and the mice died. And his first postulate is then that the microorganism must be present in every case of the disease and not present in healthy hosts. So the dead mouse, having died from anthrax poisoning, having all the signs and symptoms of that particular disease, you could look at that mouse, and you would see that in every case the mouse had Bacillus anthracis in its body. The next step that Koch set forward is that you must be able to take the microbe you extracted from the diseased animal or the diseased host and grow it in pure culture. The microorganism must be grown in pure culture from diseased hosts, so streaked onto an agar plate, for example. Then the same disease must be produced from the pure culture when it's introduced into a new host, and as long as that host is susceptible. So a whole new set of mice who were susceptible to the disease. They had not been exposed to it before, they had no immunity. Microbes were picked off from the growth plate, injected into these new mice, and the new mice developed all the symptoms, all the signs and symptoms of the anthrax disease, and they died as a result. And on to number 4, those second round of mice, the anthrax organism could be extracted, and in this example they are then able to be regrown on the agar. The same microorganism must be recovered from the experimentally infected host. So if a host has a disease, then it'll have the microbe grown in pure culture, the microbe from that pure culture introduced to a new host. The new host gets the disease. The new host is found to have the microbe in it. So sounds good and is a kind of a foundational idea. It's been around for a long time. Koch set down his postulates in 1884, but a lot has changed since then. In fact, even Koch himself realized that his postulates weren't adequate for investigating some diseases. And maybe now we know they're not adequate for investigating maybe most diseases. So postulate 1, the organism must be present in the diseased animal, but is not present in an animal that does not have the disease. I'm going to use the term animal, but should use the term organism. So the postulates were formulated before the discovery of viruses. And we know that you can be infected with the same virus, and that can lead to different diseases. So 2 different populations can have the same virus, but you see different signs and symptoms, essentially, and a different disease. That's what a disease is. It's just a list of recurring signs and symptoms. Even the same host can experience 2 different diseases from a single virus. Chickenpox in a kid and shingles in an adult, caused by the same virus, but the signs and symptoms are different. We also know that there are different pathogens that can cause the same disease. So there are many diseases, many pathogens that cause colds, many different viruses, about 100 different rhinoviruses. They'll all give you the same set of signs and symptoms. So you can't say that for a lot of things, disease X, you're going to find organism X. You could have disease X and find a whole range of organisms. You could have disease X and disease Y, and you find the same organism. We'll look at another problem with postulate 1 in a second. Postulate number 2, organisms must be grown in pure culture. This is a big problem because most organisms can't be grown in pure culture. They can't be grown in laboratory media. They need complex environments. Most likely they need to grow in a biofilm. Treponema pallidum that causes syphilis. The only way you can grow it in a controlled environment is in rabbits, which is far from a pure culture. So by stipulating that it must be able to be grown in pure culture, you are eliminating study from a whole large number of organisms. Postulate number 3, disease is produced from the pure culture. There are many diseases that you can have the pathogen, but you don't have the symptoms. You can be asymptomatic. Cholera and polio, for example. You can be infected, but you don't have the symptoms. So you could extract your microbe, you could grow it pure, you could put it into a new host, and that new host won't get the disease. Some diseases are polymicrobial, which means poly means many microbes, different species act together to cause that disease. So again, taking one species from a petri dish and putting it into a host won't cause the disease because you would need to introduce all of its kind of partners. Gum disease, for example, can't be caused by a single organism. It'll be caused by multiple organisms. Taking that pure culture and putting it into an animal model, for example, there may not be a suitable animal host. We've looked at the idea that some diseases are very, very specific. Some diseases are only going to affect humans. There's then no point in introducing that disease or that disease-causing pathogen into anything else other than a human. But clearly, no one's going to be using humans as an ends to support Koch's postulates. Postulate number 4, the organism is recovered from the diseased animal in the second round. This also applies to postulate number 1, the idea of the microbiota, that we are covered in typically harmless bacteria. Postulate number 1 was that the pathogen is present in the disease, but not in the healthy host. Healthy host can have that range of normal microbiota, and then in a few instances that microbiota can then cause the disease. So you do have the microbe present both in diseased and in healthy hosts. And therefore you could recover the microbe from an infected animal, but you may just be recovering the microbiota. So, a good idea, lots of problems because of just the way that our understanding of disease process has increased. Okay, so there are some attempts to update Koch's postulates. In the book, it has molecular Koch's postulates. I'm not sure the little section in the book there is particularly helpful, but I was looking at some ideas for updating the postulates, and a kind of an interesting one I found is based upon pathogen-associated nucleic acid sequences. So nucleic acid sequences are an ideal choice because they set aside all those problems. You can go into a diseased host, you can take a swab, you can take that swab to your lab, and you can multiply up the nucleic acid sequences, and you can read the A's, the T's, the G's, and the C's, and you can say, well, it's ATTGC, that means that it came from this organism. Obviously, a lot more complicated than that, but you don't have to grow anything. You don't have to worry about signs and symptoms. You just need to take the sample from the patient and read the sequence. That puts rest to the idea of growing the organism in pure culture. You don't need to grow it at all. Also the idea that multiple diseases can be caused by the same organism. You'll detect that because you'll swab 10 different people with 10 different diseases, and they all come back as the same sequence, therefore it's the same organism. Also put paid to the idea that there's the problem of there being multiple diseases caused by a single pathogen. You just swab the people, you will get the sequence, and that'll tell you. So, being able to read nucleic acid sequences is really one of the most important discoveries in science in the last few decades. So you find pathogens, nucleic acid sequences in organisms that are sick. And you would find the sequences where the disease is found. So if the disease is a respiratory disease, you would find the sequences in the lung. If the disease was a UTI, you would find the sequence in the tract. If there was no disease, you wouldn't find the sequences, or at least you would find a very low number of sequences. Once you got over the disease, the sequence number would decrease. If you had a relapse of the disease, the sequence number would increase. More of the sequence numbers equals worse disease, because typically more sequences means more organisms, means their ability to harm you is increased. And then a couple of checks. Does the sequence make sense? Is the sequence found where the pathogen is found? And then this whole process should be reproducible. So let's end it there. Just know what the 4 postulates are. know the drawbacks of the postulates, and then know why nucleic acid sequences are more reliable than the postulates are. Okay, that's that. Take it easy.